This is a video on inference for matched pair. It's going to look at both hypothesis test and confidence intervals. Matched pair, instead of having two separate independent groups, so maybe one group is some students from California and you're comparing some completely different students in Oregon. They don't affect each other, they're independent groups. Matched is linked together. So this might be something like a student's GPA for fall term and winter term where it's linked and it's the same person. In general, if you're looking at the same individuals for before and after, it's matched pair. If you're looking at different individuals, it's usually two independent groups. So in this scenario, I'm comparing the number of hours that a student uses the Student Learning Center, and I'm looking at the same students for both fall and winter term. So suppose I collected all this information. While knowing it's the same students, I shouldn't use the fall and winter term data. I should really just use this information for the difference. So it's not like I have two groups that I'm analyzing. I'm only analyzing one group. I'm looking at the differences. Since I'm only looking at one group, I'm back to doing hypothesis test and confidence intervals for a single average. Let me show you what that looks like using a calculator again. So in the TI-89, I'm going into apps and then stat list editor. And if I want to do the test, my tests are up here at F6. I'm going to go second F6. And I'm working with just one single variable here. That single variable is difference. And I have summary statistics, so I'll choose statistics. For the null hypothesis, I'm comparing two groups, even though it's just one difference column that'll allow me to do that. So my null hypothesis is going to be 0. 0 represents there being no difference between the fall and winter attendance for this Student Learning Center. My average is -6. My standard deviation is 2.4, and I'm looking at 31 students. They want to do a test here, and I'm looking for a difference. Since I'm looking for a difference, I'm going to choose the does not equal symbol. So this kind of has the flair of a two independent group thing for that 0 for the null hypothesis, mixed with a one sample thing where I'm only typing in the information for the differences. I'm going to choose calculate. This gives me a t-score of -13.92, and it gives me a p-value of 1.25. This e minus 14, this is scientific notation. This means move the decimal place over 14 times. So if I was writing this thing out, I would have 13 zeros. I'm not going to write it out. I'm just going to say 1.26 times 10 to the -14 is my p-value there. I have a ridiculously small p-value. Notation that gets used for this sometimes is 0 plus. It's so small, it's just a tiny bit bigger than 0. At almost any alpha level, you would reject the null hypothesis. If your p-value is low, the null must go. So this means I have evidence of a difference. When I create my confidence interval, reminder, I'm looking at the signs. So if I have negative, negative, I have done winter minus fall. So I would have, if winter minus fall is negative, this would tell me that the winter group is smaller than the fall group. If it's positive, that's the opposite. This is going to tell you the fall group is bigger than the winter group. And finally, the thing that I'm hoping I don't get is the negative and a plus. Negative and a plus is inconclusive. This was the same sort of conclusion that I had going on when I was looking at two independent averages. In my calculator, how I'm going to do the interval, instead of a t-test, I'm going to do a t-int. So I'm going to go to F7, where intervals live. Choose T-int. I'm working with statistics. And here's one of my favorite things. It fills in the data for me automatically. So I have my X bar, my S, my N. I have a confidence level, 90% confidence is fine. And I end up getting negative 6.73 to negative 5.27. Negative negative is telling me that I have evidence of a difference. More specifically, I have evidence that students spend more time in the learning center in fall than they do in winter. How much more? Well, anywhere from 5.27 up to 6.73 hours more. I want to show you how to do the same thing in the TI-84. And just as a reminder, I am working with t-interval and t-test. So in my calculator, I'm going to go stat, test. I'm choosing t-test when I'm testing for a difference. For matched pair, the null hypothesis is always going to be 0. I type in the difference information for my average. Oops. You may have noticed something there. I got an error, and the reason why I got the error is I was trying to use my keyboard to type in a negative. Negative has its own button, so I have a difference of negative 6. I have a standard deviation of 2.4, and I'm looking at 31 students. I am testing for a difference, so I'm choosing this option here, and I'm going to calculate. This gives me that same p-value, that's that second number down, of 1.26 times 10 to the negative 14. So that's 13 zeros and then a 1. This is a ridiculously small p-value. If I want to do the interval, I'm going stat, test, and I'm scrolling down to where this says t-interval. Again, one of my favorite parts about using these graphing calculators is that it automatically types in this information for me. Negative 6, 2.4, 31, be 90% confident, okay? This gives me that same interval as before of negative 6.73 to negative 5.27. Let me show you how to do this now inside of GeoGebra as well. In GeoGebra, I'm looking at t-test and t-estimate. So I'm going to go into probability. I'm going into the statistics tab. I'm going to start with the hypothesis test, so I'm going into test. My null hypothesis is always 0 when I'm looking at matched pair. I'm testing for a difference. So alternative, not equals. My average, negative 6. My standard deviation, 2.4. And I'm working with 31 samples. When I do this, GeoGebra gives me the t-score of negative 13.9194. The p-value is so small that it just says 0. Now I know technically this is a little bit bigger than 0. This is 1.26 times 10 to the negative 14. But this is what I meant by 0 plus. This is so small that some technology can't even tell the difference between it. I'm going to do the interval now. I'm looking at t-estimate of a mean if I'm doing a confidence interval in GeoGebra. Automatically types in the data for me. This time this is doing a 95% confidence interval. Okay, fine. It gives me a lower value for the interval and an upper value of the interval. If you want to change your confidence level, that's pretty easy to do. I can change this from a 95 to a 90% confidence interval, and it automatically updates for me. So inference for matched pair. It's really the same thing as inference for a single average. Just when you're doing that null hypothesis, make sure you have 0 as that number. When you're doing your conclusion, think that the conclusion is looking at the signs. If it's negative negative, That's telling you that that second group is larger. Positive, positive, first group is larger. Negative, positive, your results are inconclusive. We've now looked at averages in every way that we can possibly look at averages, except for 30 averages at once. So we've only looked at one or two, but I've not been able to look at multiple averages at a time, 3 or more. That's going to be done using something called ANOVA. There will be a calculator tutorial on how to do ANOVA as well.